Alrighty. And actually, this is Thursday, 12/6. So, starting on day 4 notes. I don't think we'll get through all of them, but we're going to do a little bit and then do a couple examples and then we'll roll on. I think the packet is in the right order from here on out. It was just those 2 pages that, but once you mess one up, it messes them all up. So, okay. Second type of sequence is called a geometric. Okay. It's also a list of terms. Okay, but instead of a common difference, it has a common ratio. Okay, so remember when we were doing the arithmetic, what meant basically it was an addition. We were adding or subtracting from each one. A geometric with your ratio is basically you're multiplying or dividing. And so this 2 has 2 different formulas. One's going to find, when you want to find the sequence, that's the form that you're going to use. Okay? And all the terms basically are the same. So a to the n is this nth term. Okay. A to the first, what's that going to be? My first term. R, this is the new one. What do you think R stands for? The ratio. Yeah. So R is the ratio or common difference, just like your 1. And then N again is going to be that the number of the term that you're looking at, for or at or whatever. Okay, so if you're looking for a specific item number, you're going to use this one. And if it's a series, actually, let's change the color. If it's a series, what was the difference between sequence and series for the arithmetic ones? Sequences was a what? Huh? Yeah, it says the sequence was the list and the series were the sums. You had the commas and the addition sums, right? Same thing here. If you have a series, it's the sum of all the terms. Okay, and so you use this formula. And all of the things, a to the 1 is still your first term. R is still your ratio. N is still the number of term. Okay? That one looks a little uglier, but it's not bad. Once you actually do it, it's not bad. Okay? Good so far? Okay, so first part is just trying to see, is it a geometric series? Okay, so you want to look for a common ratio. Like I said, that's abbreviated to BR. And that just means it's multiplied by the same value. You know, our common difference, we added the same value. The ratio you're going to multiply. Okay? So, to look at the sequence, we've got 3, 6, 12, 24. Take your first two terms and say, hey, what's 6 divided by 3? Well, that gives us 2. And then you look at the next two terms. What's 12 divided by 6? 2. What's 12 or 24 divided by 12? 2. 48 divided by 24 is going to give me 2. So that means my common ratio is 2 because it's the same on all of them. And so that means, yes, it is geometric. Good? All right, so the next one. Let's see if it's geometric. What should I do? What do you want to do first? Anybody? What were you saying? The difference is what? Say what? Yeah. Let's take 12 and divide it by 3, and so that's going to give me a negative 4. And now, let's divide negative 48 by 12. What's that going to give me? Negative 4. And then finally, what's 192 divided by negative 48? Negative 4. Do we have a common ratio? Yes. It is negative 4, and so it makes it geometric. Okay? All right, so let's use the formula and find a general rule. When it says use a formula or general rule, you're just writing the equation. Okay, so for the first one, my equation was going to be a to the nth equals a to the first times r to the n. Okay, so for the first one, what's my first term? Okay, and what's my ratio? 2. Okay, so that means that for any term, 3 times 2 to the nth, that's going to be the formula. I could find any term for that one. Okay, now go back in your memory banks to last unit. What equation does that look like? There is an equation form we did last unit. Yeah. Remember our exponential? We had a times b to the x. A was our initial value. B was our base. That's all geometric series are. Or sequences are. They're basically like exponentials. All right? All right, cool. Oh, no homework tonight. Woo woo. And then we will do a bunch of practice problems tomorrow and go from there. Good?